Hello everyone, so this is the next section that we're going to look at in the prerequisites chapter in our textbook. If you notice, I skipped P2, so we're going to jump right into P3, which is radicals. Okay, and this is again going to be a good review before we dive into more Algebra 3 trig that expects us to know all of this stuff. So that's why we're going to have a good review here in the beginning of the year. So after this video, we're just going to focus on three things right now. We want to focus on simplifying square roots. We want to then simplify square roots using the product rule and the quotient rule. So we're going to do a nice review of those concepts. And then after this video, you're going to practice them. So that's why it's super important to watch this video. Okay, so the first example, hopefully you'll find easy. Basic square roots. Square root of 36, what is it? Hopefully it's 6, right? Hopefully you think it's 6. And I know it's 6, but it's a way for me to check. Is it 6 or not? Square roots, we know, are related to squares, right? Those two is how we're going to check this, right? So 6 times 6 gives me 36. And that is the whole way that we're going to be able to check square roots. If we want to talk about some vocab, so I just refresh our memory here. That 36, the number under the radical symbol, if we weren't familiar, that's how we would say that that's the radical symbol. It's not always the square root. Eventually we'll get into cubed roots and fourth roots, but that's why we call it a radical symbol. Right now it's a square root. The number is underneath the square root is called a radicand. Okay, so if you hear me say the word radicand, you'll know that's where to look. So now, number 2, it says the square root of negative 36. Hopefully you're remembering I can't take the square root of a negative number, right? Because I can't multiply a number by itself and get a negative number. It's just not how it works, right? 2 positives are going to give me a positive number, and 2 negatives being multiplied together are also going to give me a positive. No way can I get a negative. Maybe you're thinking about complex numbers if you learned about those in the past, which is good. But for right now, we're going to say that that answer is not a real number. Okay? Notice there's a difference between 2 and 3. 3, there's a negative, but check, it's on the outside of the radical. So that's really like a negative 1 in the front here being multiplied by the square root of 36. So the square root of 36, I know that's 6. And then that negative comes down with it. So my final answer is a negative 6. So basic review there of some square roots. Let's talk about the product rule. The product rule says that when I'm multiplying 2 numbers together under a square root, so the square root of a times b, I can separate it and write it as 2 separate square roots. And I can say the square root of a times the square root of b. And then the same thing is vice versa. I can take 2 radicals that are separate and I can multiply them together and write it as 1. Okay, and we're going to use this property in the next example and in a few more examples eventually later on. So let's take a look at number 4 here, the square root of 27. Okay, square root of 27. What's the difference between 27 and 36, the first one we did up here? Hopefully, you're realizing that 36 is a perfect square, right? There's a number that you can multiply by itself to get 36. So, but that's not the case with 27, right? Square root of 27 isn't a perfect square. There's no number that I can multiply by itself to get 27. So that's when I have to use this product rule. And that's when I have to remember this trick. Now you might have learned to do this a different way, but this is a new way, okay? And you can use either way, it doesn't matter which way you pick to do it. But this is a new way maybe for you to learn about how to rewrite square root of 27. I was trying to get the highlighter, but I can't get the highlighter to go on. Okay, so what we need to do, can't do it. Square root of 27. I need to come up with 2 numbers that multiply to 27, where 1 is a perfect square. So 2 numbers that multiply to 27, what I think about a lot is 9 and 3. right? 9 times 3 gives me 27. And here's that the direct example to the product rule, right? Taking a number and separating it and writing it with 2 radicals. The best thing about doing this is now I can simplify this more. I know the square root of 9, right? What's the square root of 9? 3, right? So now I can write that as 3 times the square root of 3 because this doesn't break down at all, right? I can't rewrite the square root of 3. So there's my final answer. Okay, like I said, you might have learned like a factor tree to simplify these. Do go for it if that works for you. Doesn't matter which method. It's all up to you. Here's just a new method or the first method, whatever your prior math experience has been. Okay, so number 5 says 3 times the square root of 20. Square root of 20, right? We're realizing, oh shoot, right? 20 isn't a perfect square. So I need to break it down. I need to come up with 2 numbers that multiply to 20, where 1 is a perfect square. So numbers I think about, 10 and 2, right? 10 times 2 gives me 20. But, oh no, 10 or 2, neither of those are perfect squares. So let me keep thinking. What about 4 and 5, right? 4, square root of 4 times the square root of 5, I want to pick those because I know this right here. I know the square root of 4, right? Square root of 4 gives me 2. So notice I had that 3 right out front. That 3 doesn't disappear. I'll always have that 3 out front. The product rule, these terms are all being multiplied together. So notice now in my next step, I have the multiplication sign there. So I can multiply that to simplify it a little bit more. 3 times 2 gives me 6. There's my final answer, 6 times the square root of 5. Okay, and then this last one's the best case scenario, right? It's super easy. We need to remember the inverse, or like the opposite of a square root, is something getting squared. So when 2 things are opposite happening, they cancel each other out. So the square root of 35 squared is just 35. What a dream, right? So easy. Okay, the last one I'm going to take a look at, guys, is the quotient rule. Quotient rule is the best rule ever, or it can be the best rule ever. Basically, we should know quotient is another way of saying division, right? Or it's a fraction, right? Fraction is also representing division. So it's just like the product rule where we can do it both ways. I can either have one fraction, like the square root of a over b, and rewrite it where both the numerator and the denominator get square rooted. Or if I have the square root of a numerator divided by the square root of a denominator, we can write it as one big square root, the square root of a over b. So this example all of a sudden becomes super easy, whereas maybe before and you didn't remember the quotient rule, it would have been hard. But as soon as I see the square root of 1 over 4, I want to rewrite that as the square root of 1 over the square root of 4. And that's super easy now because I know the square root of 1, right? Square root of 1 is 1, and I know the square root of 4 is 2, okay? And that's why we love the quotient rule. It breaks things down, makes it easier for us to simplify. That's all we're going to talk about in this video, guys. We just hit those first 3 objectives today. You're going to practice. Good luck. Good job, guys. Awesome.